going to learn how to graph a quadratic. There are several ways you can graph a quadratic, but the way we're going to focus on in this course is through completing the square. There's several reasons I want to do this, which I cover in the introduction in our Canvas module. So I'm going to move straight into an example. The examples I'm going to graph are the 6 questions that we've been continuing to work with from last week to this week. So the first one is number 9. Number 9. And that is x squared plus 6x plus 8. Now in this case, instead of setting it equal to 0, we're going to set it equal to y. And you'll see here in a second, this is going to look a lot like completing the square. There's going to be a couple of small differences, but nothing really drastic. Just like in completing the square, the first thing I'm going to do is I'm going to move my constant term over to the right. So I'll have x squared plus 6x equals y minus 8. I'm now going to complete the square since my leading coefficient right here, my leading coefficient is 1, so I'm just going to go ahead and complete the square. 6, half of 6 is 3. 3 squared is 9. So I'm going to add 9 to both sides. I'm now going to factor this by perfect square trinomial. So I know I end up with x plus half of 6 was 3 squared equals y plus 1. Now, this is one of the 2 places that graphing a quadratic by completing the square differs from solving a quadratic by completing the square. Here, I'm going to bring the 1 back over, so I end up with x plus 3 squared minus 1 equals y. And now I'm ready to graph. So, the reason we would put this in this form, this is called vertex form. Okay. From it, you can tell your vertex by looking at this number and this number. So my vertex is at, now pay attention, opposite of this, which is negative 3, exactly what this says, which is negative 1. Some people refer to this as opposite, keep, opposite, keep, opposite, keep. So negative 3, negative 1. So now over here I can go negative 3, negative 1, and I can put my first dot. Now, there's an a value out here that we'll get to in a later example, but it's important to note that since there's nothing here, we assume it to be a positive 1. This is important because, number 1, it's positive, which means my parabola is going to open up like this. Okay, and this number, if this isn't a 1, it's going to affect what we do later, but right now it's not the end of the world. So, with a quadratic, here is what you do. If you go over 1, you go up 1, because 1 times 1 is 1, so squared. Think of this as we're going to square that x value. So I go over 1, up 1. Okay, if I go over 2, I go up 4, because 2 squared is 4. So 1, 2, 3, 4, over 2, up 4. And there's my parabola. So I'm going to connect those, which I did a horrible job of, so please excuse me. There's a little bit of lag in my PC, which is hard to correct for. So this side should go through that dot right there. I apologize that it doesn't. So there's my parabola, but my dots are correct. So that's kind of how you graph a parabola by completing the square. So I'm going to move into my next example. Let me do this. I'm going to copy this over. Oh, maybe we can still make this happen. Bring up my pages. I want to add a new page. Let's go in here and add a page. Oh, no. Okay. Oh, I'm not happy with the lag of this computer. Let's turn this off. There we go. Awesome. So I can tell that I'm going to need to be better prepared in the future. So let me work the next example, which is number 10. That's x squared plus 18 equals 9x. So in this case, I'm going to pull the 9x over just to get everything to the same side before I really start to think. That'll make that a minus 9x plus 18 equals, and in this case, when I'm graphing, I'm not going to put 0, I'm going to put y. Now I look at my leading coefficient, I see that it's 1, so I don't need to do anything funny. So I'm going to move my constant over, so I end up with x squared minus 9x, leave some space, y minus 18. Now this one works out kind of fun. I end up with 9 divided by 2 is 9 over 2. It doesn't come out evenly, so I'm going to leave it as 9 halves. If I square that, I end up with 81 over 4. So I'm going to add 81 over 4 to both sides. This side simplifies pretty easily. I end up with x minus 9 halves square that. Then on the other side, I have a calculator, I just don't have it on my screen, so I'm doing negative 18 plus 81 over 4. And then I'm going to do a math enter to get that back to a fraction, and I end up with y minus 9/4. I'm now going to pull the negative 9 over 4 back, so I end up with x minus 9 over 2 squared plus 9 over 4 equals y. Now I'm ready to identify my vertex, which is opposite keep. So my vertex is going to be at 9 over 2, comma, 9 over 4. Now at this point, it's okay to think of these as decimals because I have to locate them on a coordinate grid. So thinking of them as a decimal actually makes sense here. This is actually going to be 4.5, and this is going to be 2.25. So, I'm going to go to 4.5, so that's 1, 2, 3, 4 and a half, and I'm going to go up 1, 2 and a quarter. Now, I know that's not going to be perfect, but I expect it to be close. Notice I'm not touching any of the lines around me, so you can tell I don't think I go up 2. I go up 2 and a little bit more, but I know it's not going to be perfect. I'm going to follow the same idea as I did before. I'm going to go over 1. So if I go over 1 from 4.5, I get to 5.5, and I'm going to go up 1. So I'm going to go to 3.25. So do the same thing over here. Then if I go over 2, I go up 4. 1, 2, 3, 4. And this is symmetrical. So now I'm ready to connect my parabola. And I should be good to go. So there is how to graph a parabola by completing the square again. Let's do one more example. I'm going to try to pick something with a leading coefficient so that you can see what happens in that case. I'm going to go a little bit slower when I do this time. Hopefully things will go better. So far they're going more smoothly. Alright. I think that actually went pretty well. Nice. Okay, so let's pick something with a leading coefficient. That factors out. Let's pick number 11. I want you to see what you're supposed to do with a leading coefficient. Let's actually pick something. I'm going to... I'm going to adapt number 12. The reason I'm going to do so is I want to show you leading coefficient, but I don't want to run into fractions in this example because I don't want the fractions to throw you off, and therefore you're not paying attention to the process. So, number 12, I'm going to throw a 5 in front of the x squared. So this is number 12. I've just thrown that 5 in. Minus 10x plus 25 equals y. Now, if we were completing the square to solve this quadratic, we would divide everything by 5. But we're not trying to solve this quadratic, we're trying to graph it. So I don't divide by that 5. Let me say that again. Because I'm trying to graph this quadratic and not solve it, I do not divide by the 5. I'm going to move my constant term over 25. So I end up with 5x squared minus 10x equals y minus 25. Now I'm going to factor out this 5. So if I take the 5 out, notice I'm not taking out the GCF. Other instructional videos that you may find on YouTube and places mention GCF, and I'm not including the x, so you can't call this the GCF. I'm factoring out the greatest number that goes into both, okay? So this ends up with x squared minus 2x. Leave some space, close the parentheses, equals y minus 25. So far there's two differences in graphing versus solving by completing the square. Number 1, you don't divide everything by your leading coefficient. Number 2, you have to factor out the biggest number that goes into both of these so that you can complete the square inside the parentheses. So I'm going to take 2 and half it, so 2 divided by 2 is 1. 1 squared is 1. So I'm going to add 1 to this side. Now, most people are going to go over here and they're going to add 1. I cannot add 1 over here, and let me explain why. This 1 is inside of these parentheses, and these parentheses are being multiplied by this 5 out here. So I'm not really adding 1 to this side, I'm adding 1 inside the parentheses. But if I distribute this 5 across, this is going to be 1 times 5, which is 5. So the number I'm really adding is 5. I know I didn't write a 5, but that's what I'm actually adding because I have to consider the fact that I'm multiplying by this 5 out here. So, if that didn't make sense, rewind and listen again. Keep rewinding and listening until it makes sense. So what I'm going to put over here is a plus 5. Okay. Now this factors, so I'm going to end up with 5 on the outside. This is going to be x minus 1 squared. I'm going to go ahead and simplify this while I'm thinking about it. Negative 25 plus 5 is negative 20. And then if I pull the negative 20 back over, I get a plus 20. And that equals y. So my vertex is at 1 and 20. Now, obviously my grid over here doesn't have 20 spaces. I believe it's a 10 by 10. So I'm actually going to have to count by something bigger than 1s in order to graph this. So I'm going to count by 5s. Okay? So if this is 5, 10, 15, 20, I'm going to go over 1 and go up 20. 5, 10, 15, 20. Okay. Remember, I'm counting by 5s. 5, 10, 15, 20, 25, 30. Okay? Now, in the past 2 examples, I did not have this leading coefficient. I didn't have a 5. I didn't have anything out front except a 1. So what I did was I went over 1, up 1, over 2, up 4. I would have gone over 3, up 9, because I square that number. This is a multiplier. So I would go over 1, up 1, but I multiply the up 1 times 5. So I go over 1, up 5. Okay, so I go over 1, up 5. Now I'm going to go over 2, which would be up 4, but if I multiply that by 5, I get 20. So 5, 10, 15, 20. And I do the same thing over here. Over 1 more, up 20. So you can see that this is a skinny parabola, of which I'm not doing a very good job drawing. Now these are the most difficult ones to kind of get the hang of, because you end up with this coefficient out front. And a lot of people mess up how they factor it out, and a lot of people mess up how they multiply it back at the end. But I believe if we stick with this method, and all of us choose this as our preferred method for graphing, it's going to make a lot of stuff easier in the semester. This goes to translating graphs later. Vertex form is very important, so it's going to help you recognize other vertex forms. And it's also going to be important when and if we deal with conic sections. So how we break down circles, parabolas, ellipses, circles, parabolas, and hyperbolas. So that'll cover all our conic sections, and we'll be able to put them into standard form or vertex form based on completing the square. So completing the square is very important to this course and to pre-cal. I hope that this kind of made sense. You're more than welcome to go back and watch it. But we'll see how it goes. Thanks, and have a really good day.